Okay, good evening, everybody. So we're going to continue our work with solving systems of equations. That's the major file type, and we're going to get a third way of doing these today. So a third technique for solving, and this one is called substitution method. And so in substitution method, those of you who have been all year long, working and trying to apply the use of parentheses whenever we take a letter out and put something else in its place, is the first time that this is really going to start giving some bang for your buck. So this is one of the later skills that I've been telling you guys about, where if you use the proper techniques, you'll start to reap some benefits from it. So you'll see that today in some of the other later examples. Okay, so what we have here is we have two equations that are in y form, and of course the systems of equation, because we have two equations with two variables. And you could probably solve this one pretty easily using any of the three methods. We could graph it because it's already in y form. You could multiply by a -1 to eliminate one of your x's. And we're going to learn the third form, which is substitution method. And what's going to happen is, as we get better at all three of these different methods, you're going to pick the one that is best for each problem, or the one that you're best at for that problem. So for this one, we're going to go ahead and use the substitution method. So what I'm going to look at here is I see that this y right here is going to be the same as this y right here. We're trying to find that point of intersection. And somewhere between these two lines, this y will be equal to this y. So if this y is equal to this y, and this y is equal to 2x minus 7, that means at some point, this y right here is equal to 2x minus 7. And this y right here is equal to 5x plus 11. So then what we can do is we can take this and plug it in for this right here. And so what I have on the left hand side is 2x minus 7, and I took the y out and I put that in its place. So I leave the parentheses, and on this side I have 5x plus 11. And there's nothing really for us to do with these parentheses, like we don't have to distribute or anything, so I can just take them off on at the next step. And then I have x on both sides, so my next step, of course, is to get rid of the smaller x. So I'm going to subtract 2x from both sides. On the left-hand side, I have -7, which is equal to 3x plus 11. And then my next step is to subtract 11 from both sides. And I get -18 is equal to 3x. And then lastly, divide by 3. So x is equal to -6. So I found my x, and of course I need to go back and find my y, so I can pick either equation that I want. I'll pick the top one. So I have here y equals 2 times -6 minus 7 equals -12 minus 7, so y is equal to -19. So then these would be my x and my y, and my coordinate pair would be -6, -19. Okay, so that is one type of substitution method we could do. Another type of substitution method is when it looks like this. Now in this problem, we don't have both of them in y form. We only have one of them in, whoa, that was kind of weird. We only have one of them in y form. We just have this one. This top one up here is not in y form. So this is a little bit trickier to do elimination or graphing, because they're not both in y form, and elimination is tricky because that equal sign is not lined up. So it looks like we might be able to do something with the x's and the y's, but it's one we can oftentimes make mistakes with. So this is definitely one where I would use substitution. And what I have found, what I notice is that for some point on my graph, this y right here is going to be equal to that y. Therefore, this y is going to be equal to the x minus 1. So here's where the parentheses really start to pay off. I have 3x plus 2, and now parentheses, x minus 1 is equal to 8. And when I use my parentheses instead of the dot, then I hopefully remember that I need to distribute. So then I have 3x plus 2x minus 2, which is equal to 8. And then I have x on one side, so I'll combine like terms. 5x minus 2 is equal to 8. Add 2 to both sides. 5x is equal to 10, and of course divide both sides by 5. So x is equal to 2. And then of course we have to go back and find the original inequality, or equation I mean, the y value. And so I'm going to use this one here, and I'm going to say y is equal to 2 minus 1, so y is equal to 1. So then my answer would be 2, 1 for my coordinate pair. Okay, so that's the second time that we might want to use the substitution method. There's one more, and we'll take a look at that right now. I'm not sure what happened right there. That's it for my lesson. I will see you tomorrow. I'm sorry. Something went weird with my recording. There's a third slide, so if you're still on the second slide and you haven't seen the third slide yet, continue watching the video. There's one more example. I'm really messing this up. I'm sure I'll hear about it. All right, see you later. So this one looks like this. So it's a little bit different because we don't have either of them in a y form. And so I probably would not graph this one. This would not be one where I would most likely graph. I like to graph the ones that are in y equals mx plus b format or y form. Since these aren't, I probably wouldn't graph. I could use the elimination method. If I wanted to eliminate it, I would need to pick which of my variables, either my x or my y, I want to eliminate. I probably would think about eliminating the x. If I want to eliminate the x, I need to make this coefficient the same number as that, but make it the opposite sign. So I might multiply this top one by -4. If I make the whole thing by -4, then I can eliminate those and finish the elimination method. That's kind of tricky, kind of a lot of work. We're going to try and do it using the substitution method instead. In this case, do the substitution method, I want to get one of my variables by itself. I don't care if I get that x by itself, or that y, or that x, or that y. One of these variables has to be by itself. I'm going to do the easiest one that I have. The easiest one that I have is going to be the x value. So I'm going to subtract 2y from both sides. So on the left-hand side, I get x equals, and the right-hand side, I get -2y plus 4. Now, what I have is I have my x value, and that x is the same as this x over here because it's in the same problem. So I can take this x, which is this, and sub it in for that. So I'm going to have 4 times, and then I take this and plug it in to there. So it's going to be 4 times -2y plus 4. And then plus 3y is equal to not 8. Where did that come from? Aichi mamas, people. What's going on? It's equal to 1. Okay. So then, once again, we use parentheses, so we're going to use our distributive property. So I get -8y plus 16 plus 3y is equal to 1. And then I'm going to combine like terms. So I get -5y plus 16 is equal to 1. Then I'm going to get rid of my 16. At this point, of course, we're just pretty much doing the same process we've done for over a year now, actually. Is equal to -15. And then lastly, divide both sides by -5. So what I end up getting is y is equal to 3. And once again, y is equal to 3, so I still need to calculate and figure out what my x is equal to. So I'm going to do that. I'm going to use this one right here, and I have x plus 2 times my 3 over here, that 3 right there. 3 is equal to 4. So x plus 6 equals 4, so x is equal to -2. So then my coordinate point would be -2, 3. And that is my answer. Okay? Okay, so that is 3 ways of doing the substitution method, and we're going to start to use them interchangeably, and you're going to start picking which of those methods is the best one for the information that's given. Once again, this goes back to having multiple ways of getting to Los Angeles. We want lots of different freeways. This gives us 3 different freeways that we can get to LA.